All right, last but not least, last page, topic 5, our applications of all of our right triangle relationships in trig. Town Park does an outdoor movie night every Saturday during the summer on a large screen. Kate is sitting, so let's say Kate is over here. Hi, Kate, there you are. 36 feet from the base of the screen, so let's put the screen up over here. Kate's 36 feet from it. The angle of elevation from Kate to the top of the screen is 24 degrees. The question is, how tall is the screen? So we have a tangent relationship, opposite and adjacent. The tangent of 24 equals S, you can use whatever variable you want, over 36. S is going to be equal to 36 times the tangent of 24. Undo my divide by 36 by multiplying by 36. And perfect example here, make sure you are using units. It's in context. The screen is 16 feet tall. 36 times the tangent of 24. Still rounding to the 10th too. Just watch for your roundings. Elijah's looking up to the top of the Washington Monument. Here's little Elijah over here. Hi there, buddy. He's looking up. The monument is 555 feet tall. So here's our Washington Monument over here, and we know that it's 555 feet tall. Angle of elevation from the point on the ground where Elijah's standing to the top is 74 degrees. How far is he standing from the base? So I'm going to put my X down here. How far away is he? I'm looking at an opposite and adjacent related to the 74. The tangent of 74 is equal to 555 over X. Multiply both sides by X to get it out of the denominator of our fraction. Finish solving for X by dividing by tan 74 on both sides. And you should find that it's about 159.1, and this was measured in feet as well. Well, parasailing, Ryan spots a dolphin in the water below. So here's Ryan up in the air. Here's our, I'm going to deal with an angle of depression. Whoa, whoa. He sees a dolphin. We're going to assume that he sees the dolphin off in the distance over here. So here's where the dolphin is. The angle of depression was 15 degrees. We knew one other thing. What was it? Oh, he's 228 feet. So the water line is down here. This is where the water line would be, where he sees the dolphin. What's the horizontal distance between Ryan and the dolphin? So we need to know this distance right here. The angle here would be 75. 90 minus 15 is going to put a 75-degree angle there. So we're dealing with a 75. We've got an opposite and an adjacent. So the tangent of 75 equals X over 228. So X is going to be equal to 228 times tan 75. I'd multiply both sides by it to undo the divide by 228. And you should have 850.9 feet. 850.9. I know some of the issue with some of these problems was getting a handle on the drawings. I'm going to recommend that over the evening that you just go back to everything that we drew, particularly ones that you know you had to ask about or you were like not sure and we talked at length about. But review your drawings because there's a handful of questions that you will have to draw and solve like this. Number 29. Okay, so 29, you guys already gave me a heads up. This is one where we have, you know, like a difference in heights that we need to deal with. An angle of depression from an airplane to the top of an air traffic control tower is 56 degrees. So if I've got my plane up here, my plane is flying along. I'm drawing that for my angle of depression. The control tower, I'm going to put my control tower right over here. The angle of depression here is 56 degrees. The control tower itself is sitting here at a height of 320 feet. The control tower is 320 feet off the ground. The airplane is flying at a height of 7,450 feet. How far away is the airplane from the control tower? Well, that's this distance down here, but I just created a quadrilateral. So what I want to do is modify my quadrilateral by just using a parallel line relationship here, and because this distance along the ground is going to be the same distance if I'm up here. I've created a right triangle, but I do need to modify this side length. 7,450 minus 320 is going to be the length of this leg. Who has that number? 7130. Yep, that seems reasonable. And then if I've got a 56-degree angle out here, what's the measure of the angle inside? 34. So I'm dealing with, related to the 34-degree angle, I have the opposite and I have the adjacent. Tangent of 34 is x over 7130. Multiply both sides by 7130. 7130 times the tangent of 34 is going to give us our x. X is approximately 4,809.2 feet. We want this horizontal distance. We already dealt with the difference between the height of the tower and the altitude of the plane, so there's no need to make any adjustments here. I made my adjustments for the difference in heights already when I went to solve the problem. Now, last problem, lighthouse, angle of depression from the top of a lighthouse, 275 feet above water to a boat. All right, so here's the top of my lighthouse. Lighthouse, there we go, LH. Here's the top of my lighthouse. Let's say that this is the water line. We know that there is a boat somewhere over here. There's a boat. Here it is. Couple things we know. The lighthouse is 275 feet. The boat is, this is going to be the shore. Right here is going to be shore. And what we know about the boat is that it is 1,324 feet offshore. So we're going to assume that it's 1,324 feet away from the lighthouse. And we have an angle of depression. Oh, they want the angle of depression. We need this. Let's go find this and subtract from 90 to get the angle of depression. Be careful with these. Remember, the angle of depression sits outside here in my drawing. So I'm going to solve this for y, and then I'm going to go back and use it to find that angle of depression. So what do I have? I have opposite and adjacent. Tangent of y is going to be opposite and adjacent. 1324 over 275. So the tan inverse on 1324 and 275 is going to give me my y. What is it? So when I find y, I have 78.3 degrees. That's here. 90 minus 78.3. What is that, 11.7? Okay, that's going to be your angle of depression for this problem.